All right, let's. This is my second try, by the way, so I might seem a little tired because let's try this again. So what we're going to talk about today is we're going to talk about how to simplify a complex slope. So whenever we're trying to analyze the meaning of the slope, things of that nature, we have to ask ourselves, what are the units telling us? What do they mean? And sometimes to get the most out of that, you have to be able to simplify them, especially if they're weird and complicated. So that's what I'm going to talk about now. So fundamentally, slope, as a general idea, is defined as your change in y over your change in x. So it's how your y idea is changing with respect to how your x idea is changing. So this one we got a number of 3.2. I chose some random things. That's totally random, by the way. So I said mass in kilograms on the y, speed squared, I squared just to have fun, is on the x, so it has units of meters squared per second squared, because yeah, square everything. And that's on the x. And so now I'm going to figure out, okay, what would my units be? So I'm mostly focusing on the units here. So technically my slope would be 3.2, and then my y is kilograms, and then my x is meters squared per second squared. And you might say, yay, I'm done, but math teachers all across the world are going, oh my god, it's a compound fraction. So you need to simplify this. Okay, you can't leave this as fraction over fraction. You just can't do it. So what I'm going to talk about now, using other colors, let's go blue. I'm feeling blue today. All right, so I'm going to talk about this here. I'm just going to bring that out. And we're going to talk about how to simplify this. So this becomes kilograms divided by meters squared per second squared. All right. Now to simplify, we're going to use a little math knowledge. So I'm going to multiply. I'm going to use the little x instead of a dot. We're going to multiply by the by the inverse of this to get rid of it. But in order to do that, you just can't like multiply by the inverse. You actually have to multiply by the number 1. Now, why are we multiplying by the number 1? Well, if you multiply anything by 1, it doesn't change. 10 times 1 is 10. 5 times 1 is 5. Multiplying the number 1 doesn't do anything. So we actually ask ourselves, what are things that equal the number 1? Well, 1 is equal to, say, 5 over 5, because we have the same idea on top and the same idea on bottom. So as long as we have the same idea on top, the same idea on bottom, we're multiplying by the number 1. All right, so that's an example. It's not the only one there is. So we're going to replace this 1 with the same idea on top and the same idea on bottom, but because we want to cancel out with this, we're going to put the inverse in there. So check this out. All right, so I'm going to multiply this by the inverse of my denominator. So I'm going to multiply this by seconds squared per meter squared. And then I'm going to multiply this by seconds squared per meter squared. All right? And when you multiply, just multiply across. So what this now becomes is kilogram seconds squared per meters squared divided by meters squared seconds squared divided by, well, technically order doesn't matter, but you really get meters squared seconds squared. Wow, that's really ugly. Oh wait, is it? No, it's not so bad because new color, because this right here is the number 1. And anything also divided by 1 is itself. So in a way, we usually say, oh, this cancels out. Okay, well, it cancels out because it equals the number 1. So then we're left with kilogram seconds squared per meter, and that is our final equation. I should say our units for our final answer. So if you ever have something complicated, what you're really going to do in recap is you're going to multiply by the number 1. And so you're going to have some sort of fraction over some sort of fraction. You want those fractions to be the inverse of these. So notice how I had seconds went on bottom to top, so I basically just flipped the order of these. And then you multiply across. This stuff all cancels out because it really just equals the number 1, and we're left with what's on top. All right? So that's how you simplify a complex slope. So I hope that was helpful. If you have any questions, as always, feel free to ask. Bye-bye.